Hello, thank you for where you are. Um, uh, it's Summit. So this is a one-day virtual event. Do not miss the last session of the day in order to have a chance to win an amazing prize. Not hesitate to support this course by the and I also created an organization which is called Curiosity, and we want to help people to pass their high education by providing free coaching to them. So, and in the Curiosity mindset, we are
Hi, still
putting
Vignesh here. I
many
mean,
women.
your voice is breaking actually.
Yeah.
I think there is some problem with your network. If you could just check that. Your voice is breaking.
Problem with the sound or with do you want me to stop the camera in order to spare the bandwidth?
Yep, maybe that could help. Yeah, let's try that.
Okay, so switching the webcam. Can you hear me well?
Yeah, this is fine. Just keep talking. I'll let you know if at all your voice breaks. Yeah. You can carry on, still. Yeah.
Okay, so I'm continuing.
Yeah.
Okay, so just to continue, Curiosity, we want to help many people is like Asperger or dyslexia and underprivileged people. So presenting myself. I'm Estelle Oberix. I am focusing on innovative human-centric innovation, which means that I create solutions depending on real human needs, not on technology. And I am a co-founder of Azure FR, which is a French-spoken Azure user group, and Curiosity, the non-profit organization I just presented you. You can easily follow me or contact through a social network like Twitter or LinkedIn. So today in the agenda, we will have a quick introduction to cyber threats. What is the threat hunting? Threat hunting in Azure. We will have some demo through the session, and we will see with Microsoft Defender and also Microsoft Sentinel. So, and we will finish this session by some links to go if you want to go further in this subject. So according to cybersecurity ventures, global cybercrime costs will grow by 15% per year over the next 5 years, reaching almost $10.5 trillion annually by 2025. So cybersecurity refers to technologies, processes, and trainings that help protect systems, networks, programs, and data from cyber attacks, damages, and unauthorized access. And cybersecurity enables you to achieve the following goals: the confidentiality, which is the information that should only be visible to the right people; integrity, it's information which should only be changed by the right people or processes; and availability, which is information which should be visible and accessible whenever needed. And this is commonly referred to has the confidentiality, integrity, availability, which is called the CAA model in the context of cybersecurity. Throughout the rest of this module, and in this session, you will learn about some tip attacks, several criminals, and used to manage the cyber hunt. So it is critical to understand the shared responsibility model, including which security task the cloud provider handles and which tasks are handled by you as the customer. And the workload's responsibilities varies depending on whether the workload is hosted on software as a service, platform as a service, infrastructure as a service, or on-premise data centers. This slide illustrates the areas of responsibility between the user and Microsoft according to the type of deployment and services. And so in a shared responsibility model, a layered approach to security is described as follows. So for on-premises solution, the customers is both accountable and responsible for all aspects of security and operations. For IaaS solutions, the platform vendor manages the elements such as buildings, servers, networking hardware, and hypervisor. And the customer is responsible or as a shared responsibility for securing and managing the operating system, network configuration, applications, identity, clients, and data. For PaaS solutions, which is built on IaaS deployments, and the provider is additionally responsible for managing and securing the network controls, and the customers is still responsible or has the shared responsibility for securing and managing applications, identity, client, and data. So for SaaS solutions, a vendor provides the application and abstracts customers from the underlying components. So there are many different approaches to increasing an organization's cybersecurity defenses against adversaries. So one fundamental solution is known as the threat hunting. So threat hunting provides a proactive opportunity for an organization to uncover attacker presence in an environment. So there are plenty of threat hunting and threat detection definitions in the market, and sometimes this generates confusions or noises about what your customers think they need to improve their security postures. So let's try to clarify the differences between threat hunting and threat detection and see how they can benefit your customers. Threat hunting is a process of seeking out adversaries before they can successfully execute an attack. And threat hunting is an early stage component of threat detection focused on identifying threats at the earliest possible phase of an attack or compromise. And threat detection as a broader term refers to the complete set of processes focused on identifying threats, whether before, during, or after a compromise has occurred. So threat hunting tools analyze endpoints, applications, data, and user behavior for an anomalous activity indicative of a threat. So here on this slide, I put you the main differences between them. So the threat hunting is, like I already said, is a proactive technique that combines security tools, analytics, and threat intelligence with human analysis and instinct. And threat hunters do not wait for an alert about known patterns. Instead, they try to find clues before a data breach occurs or before an unknown or malicious binary is detected on the endpoints. Threat hunting is inspired by suspicions and the formulation of new hypotheses. And the hunt is to follow clues and ideas rather than to verify known rules. And only analysts specialized in the search for attack patterns in this type of data, the threat hunters, can provide this service. So threat hunters rely on their knowledge, experience, and mindset aligned with the hacker's way of acting, knowing at all times that the client's security is being compromised, focusing on locating any clue that allows identifying the attacker in the network without an alert or of detection of unknown rules or malicious binary. And threat detection is a process that is automated and oriented to detect known threats in most cases. So, in contrast, threat hunting is a creative process with a flexible methodology focused on hunting the hacker. So, like I just told you, threat hunting is human driven, iterative, and systematic. So, hence, it effectively reduces damage and overall risk to an organization. Its proactive nature enables security professionals to respond to incidents more rapidly, and it reduces the probability of an attacker being able to cause damage to an organization and its system or its data. This is vital to ensure that confidential data isn't misused or accessed by unauthorized individuals. So an organization's executive leadership or management must guide the purpose of a threat hunt to meet larger long-term business objectives. And the three areas of study defined with the purpose stage include the purpose of the hunt. So the overall purpose states why the hunt needs to occur. So where the hunt will occur. This is the purpose also includes um, scoping the environment as well as identifying assumptions and limitations of the hunt and desired outcomes of the threat hunt because the desired outcome should align with business objectives and indicate how the threat hunt supports reduction of risk. So here's some common example of why a hunt takes place. For example, connection of a new network to an existing trusted network following a corporate merger or acquisition. Another example is a new threat intelligence suggesting the presence of an attacker in the environment. You also have as an example, the desire to gain a higher awareness and confidence of the environment. So here's a checklist for any organization where threat hunting comes into play. So planning in order to identify critical assets. Detections, you search for known and unknown threats. Responding to manage and contain attacks. Measuring it's a good the impact of the attack and the success of your security. Preventing, you have to be proactive and stay prepared for the next threat. So organizations of all sides and industries would prefer to detect every possible threat as soon as they are manifest. And this is a primary outcome of increased spending on automated cybersecurity solutions. So threat hunting entails a more mature organization with a defensible network architecture, advanced incident response capabilities, and a security monitoring or security operation team. So a relatively mature organization can start a threat hunting program by planning and allocating time and people, but the undertaking does not call for expensive tools or years of experience. Small and medium-sized organizations could start with simple and progressive steps and gradually extend on the data types and scenarios. So the threat modeling is the heart of threat hunting. There are different methodologies defined for threat modeling, and threat modeling should be improved over time by expanding the coverage and threat actors targeting the organization or same industry, and or using similar platforms and attack applicability. There were two prerequisites for threat modeling: the asset inventory, which critically levels should be defined, and for each of those assets, security mitigation and defense controls, including but not limited to firewall, IDS, anti-malwares, endpoints detection response, the data leakage prevention, authentication, authorization, and of course encryption control. That's just some example. So threat modeling is a systematic approach of proactively assessing the weakness of the IT environment and assets, and based on their critically level and potential vulnerabilities, a remediation plan should be developed. There are several threat modeling methodology available. One of the leading industry models is the Microsoft Security Development Life Cycle, which is also called SDL, and it's as known in this schema. So it defines the threat modeling approach in the following 5 steps. First step is defining the scope and depth of the analysis. So at this stage, the scope and depth of threat hunting should be defined based on threat modeling, obtaining a list of assets and their critically assists with the rest of the process in scoping and defense and remediation planning. Step 2, gaining an understanding of what you are threat modeling. At this stage, based on the collected system, threat hunters should understand the components of each asset. It helps them to profile the standard architectures and flag it in the future if suspicious changes and interconnections take place. So architecture diagrams at this stage should be gathered for further review. And furthermore, the business workflow gives the required insight to threat hunters for future behavioral analysis. Step 3, modeling the attack possibilities. So defining a list of assets, existing security control, and identified vulnerabilities and misconfigurations. So in the next stage, a system architecture outlines a potential triggering threat agent or failing the controls that could lead to an incident. It's now the step 4, which is interpreting the threat model. So at this stage, threat hunters should wear their hacker hats and think similar to a hacker and analyze the possibilities. Having the threat intelligence feeds at this stage helps to extract the required knowledge of threat actors and the TTPs and the TTPs. So additionally, threat actors should constantly think of alternatives to bypass certain control and be proactive. And last step is the step 5, creating a traceability matrix to record missing or weak controls. At this point of threat modeling, based on the finding, mitigation control should be assessed with the threat agent, asset, attack surface, attach goal, and impact. So note that during this stage, business objectives and strategy should also be strongly considered. So, for instance, if it is a military organization, confidentiality and integrity are paramount. So, applying this to a financial sector organization, availability should be added to as an additional key concern. So you can use the Metro attacks framework in analytics, rules and incidents. So having a schedule rule with Metro techniques applied running regularly in your Microsoft Sentinel workspace enhances the security status shown for your organization in the Metro coverage matrix. So you have the analytics rules. This is when configuring analytics rules, select specific meet techniques to apply to your rule. And when searching for analytics rules, filter the rules displayed by technique to find your rules quicker. For incidents, this is when incidents are created for alerts that are suffered by rules with metric techniques configured, and the techniques are also added to the incidents. And then the threat hunting, this is when creating a new hunting query, select the specific tactics and techniques to apply to your query. So when searching for active hunting queries, filter the queries displayed by tactics by selecting an item from the list above the grid that you can see on this slide and select a query to see tactic and technique detailed on the right. So when creating bookmarks, either use the technique mapping inherited from the hunting query or create your own mapping. So the threat hunting in Azure. Threats can come from anywhere, whether from bad actor trying to compromise system due to poor security hardening and patching, lack of security controls, or employees not following their organization's best practices or falling into social engineering traps. Organizations should manage their threat landscape from end to end using the integrating and comprehensive security, compliance, and identity management solutions. Microsoft has an arsenal of tools and technologies to bring all these capabilities together, whereby it allows developers to natively integrate individual layers of protection to improve end user experiences, decrease SecOps inefficiencies, and reduce the risk of costly data breaks and compliance violation. The Microsoft Defender for Cloud brings advanced intelligence protection of your Azure and hybrid resources and workloads, and the workload protection dashboard in Defender for Cloud provides visibility and control of the cloud workload protection feature for your environment. The other service is the Microsoft Sentinel, which is a scalable cloud-native security information event management, which is also called a CM, and security orchestration automated response like a SOR solution. The Sentinel delivers intelligent security analytics and threat intelligence across the enterprise, providing a single solution for alert detection, threat visibility, proactive hunting, and threat response. So, like you see on this slide, for identity and asset management, you have Microsoft 365 Defender, which is a unified pre- and post-breach enterprise defense suite that natively coordinates detection, prevention, investigation, and response across endpoints, identities, email, and applications to provide an integrated protection against sophisticated attacks. Microsoft Defender for Endpoint is an enterprise endpoint security platform designed to help enterprise networks prevent, detect, investigate, and respond to advanced threats, like malware, for example. And Microsoft Defender for Identity is a cloud-based security solution that leverages your on-premises Active Directory signals to identify, detect, and investigate advanced threats, compromised identities, and malicious insider actions directed at your organization. The Azure AD Identity Protection sends two types of automated notifications emails to help you manage user risk and risk detections. So users at risk detected email and weekly digest email. So for infrastructure and network, you have Azure Firewall. So Azure Firewall Premium provides a signature-based intrusion detection and prevention systems to allow rapid detection of attacks by looking for specific patterns such as byte sequences in network traffic or non-malicious instruction sequences used by malware. Microsoft Defender for IoT is a unified security solution for identifying IoT or OT devices, vulnerabilities, and threats. So it enables you to secure your entire IoT or OT environment, whether you need to protect existing IoT or OT devices or build security into new IoT innovations. Azure Network Watcher provides tools to monitor, diagnose, view metrics, and enable or disable logs for resources in an Azure virtual network. So Network Watcher is designed to monitor and repair the network health of IaaS products which includes virtual machines, virtual networks, application gateways, and load balancers. Azure Policies helps to enforce organizational standards and to assess compliance at scale. And Azure Policy uses activity logs, which are automatically enabled to include event source, date, user, timestamps, source addresses, destination addresses, and other useful elements. And then for data and application, you have Microsoft Defender for Container Registries, which includes a vulnerability scanner to scan the images in your Azure Resource Manager based Azure Container Registry registries and provide deeper visibility into your images vulnerabilities. Microsoft Defender for Kubernetes provide cluster-level threat protection by monitoring your AKS managed services through the logs retrieved by Azure Kubernetes Services. And Microsoft Defender for Cloud Apps is a cloud-based security broker that operates on multiple clouds, and it provides rich visibility, control over data, travel, and sophisticated analytics to identify and combat cyber threats across all your cloud services. So in the last section, I told you that the threat hunting is proactive. So why is that crucial? As you hunt for not previously detected threats, the concern is that if you wait for the threat to be detected, the compromise impact could be more significant. If you don't have a known indicator, then what are we hunting? We hunt based on hypotheses, and the hypothesis might start with operational threat intelligence and then list the attacker's tactics and techniques. Hypotheses can search for a specific technique, not an indicator like an IP address. If malicious activity is identified, we might have discovered the attacker earlier in the attack process before they have an opportunity to exfiltrate data. Threat hunting should be a continual process. So we start at the top of our circle with our hypothesis. Our hypotheses help us plan out what we are going to hunt for, which requires us to understand where we are going to hunt and how we will do it. This means we need to understand the data we have, the tools we have, the expertise we have, and how to work with them. And the hunting cycle doesn't stop when they execute the hunt. There are still several phases we need to conduct throughout the life cycle, including responding to anomalies. Even if we don't find an active threat, we will be activities to perform routine tasks, and that should include setting up new monitoring, improving our detection capabilities. Everything done in threat hunting should be documented. Documentation for the hunt should include what, how, and why, input and output, how to replicate the hunt, and next steps. So Microsoft 365 Defender is an integrated threat protection suite with solutions that detect malicious activity across email, endpoints, applications, and identity. These solutions provide a complete attack chain compromise story that enables a complete understanding of the threat and enables you to remediate and protect your organization from future acts. So Microsoft Defender for Endpoint or Microsoft Defender for Cloud, that's a platform designed to help enterprise networks prevent, detect, investigate, and respond to advanced threats on their endpoints or application like malwares or other kind of threat. In this example, in this sample attack chain graphic, you can see the attacker activity visible to each Microsoft 365 Defender product. And you need to understand how extended detection and response, which is also called XDR, combines signals from endpoint, identity, email, application to detect and mitigate threats. You can see here a sample security operation model. So we'll start with handling reactive alerts, which begins with automation at the bottom of the slide, and near real-time resolution of known incident types with automation. These are well-defined attacks that the organization has seen many times. To give you an idea of how these work, let's follow the common incident life cycles. So from the button, we're going to go to the trials for the tier 1. So trials analyst claims a malware alert from the queue and investigates, for example, with Microsoft 365 Defender Console. And while most triage cases are rapidly remediated and closed, this time the analyst observes that malwares may require more involved or advanced remediation. Triage escalates the case to the investigation analyst, which is a tier 2, and who takes lead for investigation. So the triage team has option to stay involved and learn more. This is the investigation team may use Microsoft Sentinel or another CM for broader context. And during the investigation, we verify the investigation conclusions or dig further into it and proceed with the remediation and close this case. So later, the hunt is a tier 3 may notice this case while reviewing closed incident to scan for commonalities or anomalies worth digging into, detection that may be eligible for auto-remediation, or multiple similar incidents that may have a common root cause, or other potential process, tool, alert improvements. And in one case, Tier 3 reviewed the case and found that the user had fallen for the tech scam. So this detection was then flagged as a potentially higher priority alert because the scammers had managed to get admin level access on the endpoint. So this is a higher risk exposures. So advanced hunting is a query-based threat hunting tool that lets you explore up to 30 days of raw data. And you can proactively inspect events in your network to locate threat indicators and entities, and the flexible access to data enables unconstrained hunting for both known and potential threats. So you can use the same threat hunting queries to build custom detection rules, and these rules run automatically to check for and then respond to suspected break activities, misconfigured machines, and other findings. The advanced hunting capability supports queries that check a broader data set from Microsoft Defender for Endpoint, Microsoft Defender for Microsoft 365, Microsoft 365 for Defender, Microsoft Defender for Cloud Apps, or Microsoft Defender for Identity. Advanced hunting data can be categorized into two distinct types, each consolidated differently. The event or activity data, which populates tables about alerts, security events, system events, and routing assessment. And then the entity data, which populates table with information about users and devices. And this data comes from both relatively static data sources and dynamic sources, such as Active Directory entries and event logs. So to provide fresh data, tables are updated with any new information every 15 minutes, adding rows that might not be fully populated. Every 24 hours, data is consolidated to insert a record that contains the latest, most comprehensive data set about each entity. So to use advanced hunting, you have to turn on Microsoft 365 Defender or Microsoft Defender. And here is a little presentation of the advanced hunting features in the Microsoft 365 Defender.
Microsoft Defender ATP gathers a huge store of information that can help you detect, investigate, and respond to advanced threats. In this video, I'll demonstrate how to use advanced hunting to query and use all that data. Advanced hunting is a powerful query language that's flexible and rather simple to use, especially considering it uses IntelliSense to autocomplete operators as you build queries to mine the telemetry that Microsoft Defender ATP stores in tables. For example, you can query process creation, network communication, and many other event types. Detailed schemas are available for all of them. Some results, like machine and file names, link directly to detail pages in the portal, helping you pivot easily between the advanced hunting and portal investigation experiences. Big time saver. And last, the welcome page provides basic and advanced examples to get you started with the tables and query language. In Microsoft Defender Security Center Advanced Hunting page, the sidebar shows the schema you use to build queries. There's one list for each table, like machines or alerts, and each list contains the table's columns. For example, columns in the File Creation Events table include the file name, folder path, hash, and many other data points. Likewise, the Machine Info table contains columns for the operating system, IP address, and so on. I'll use these tables later to build an advanced query. You won't find a description of these columns in the schema, but take a look at the Advanced Hunting column reference. It provides detailed information about each, including its data type and description. Before showing you how to build advanced queries using this schema, we recommend getting to know the basic examples. That's next. The Get Started section contains examples that show how to query Microsoft Defender ATP telemetry. There are two sets, Basic and Advanced. I'll start with the basics. Under Project, select Run Query to run the example. This is a simple query language that has elements of PowerShell, like the pipe character. It uses the where operator to select rows from the File Creation Events table created in the last hour. The limit operator restricts the results to 1000, and the project operator selects specific columns, like the file name and event time. Below the query are the results. To view details about an entity in them, like machine details, select the hyperlink to open them in a new tab. With this basic example under your belt, building a custom query that extends it is a great learning opportunity. Next. Ultimately, I want to build a query similar to the basic example, but I want information about machines that are defined as high-value assets, along with the number of failed logins. So, I'll start with the Machine Info table and filter the results to show machines that are tagged as a high-value asset. To select the columns I want, add the project operator, followed by a comma-separated list of columns. Last, use a join operator to merge the Machine Info and the Logon Events tables to include logon events in the query. This way, you can hunt through a smaller number of failed logon attempts for the most valuable assets in the org. That's it. Run the query and you see the results. Results are clickable and bring you right to this specific event on the machine timeline. Next, I'll show the advanced filter capabilities you can use to refine the results further. After running a query, you can filter its output. Each column in the results has a section in the filter, and within each, you see a list of unique values for that column sorted by prevalence. Find the query by clicking the plus or next to a value to include or exclude result. The filter adds a where operator to the query state. Run the query again to update the results. Another nice ability is custom detection based on my own queries. I'll describe how to do that in the next segment. Custom detection rules are queries that run as a scheduled task. When the query has results, it surfaces an alert, just like any other alert. They do require the event time, machine ID, and report ID columns in the query. I'm missing the event time and report ID columns, so I'll slip those in there. Once the query is ready, creating the detection rule is simple. It needs a name, metadata like the severity and category, and a description. Select Create to save the rule. After the query runs, here's what the custom alert looks like in the Security Operations Dashboard and the Incidents Dashboard.
So Microsoft Defender for Office 365 include best-of-class threat investigation and response tools that enable your organization's security teams to anticipate, understand, and prevent malicious attacks. So the threat trackers provide the latest intelligence on prevailing cybersecurity issues. For example, you can view information about the latest malware and take countermeasures before it becomes an actual threat to your organization. The Threat Explorer real-time detections, also referred to as Explorer, is a real-time report that allows you to identify and analyze recent threats. You can configure Explorer to show data, and you also have a network simulator which allows you to run realistic attack scenarios in your organization to identify vulnerabilities. So here's an extract of an interactive guide, investigate and remediate a threat with Microsoft Defender for Endpoint, and you will watch the threat analytics dashboard, which is a great jump-off point for getting to the reports that are most relevant to your organization, and an example of a live investigation and the use of Power BI to facilitate your threat hunting.
Threat analytics is a set of reports published by Microsoft security researchers as soon as emerging threats and outbreaks are identified. The threat analytics provides an overview of the threats covered in these reports. It shows the latest threats, high-impact threats, and a summary of the threats that impact your organization. Select the Living Off the Land threat to view its report. Each threat report provides the threat and an analysis of the techniques and tools used by the threat. It also provides worldwide impact information, mitigation recommendations, and detection information. Each report also includes several cards that show dynamic data about how the organization is impacted by the threat and how prepared it is to stop the threat. Next, scroll down to review the report. Now let's navigate to the machines list to look at another way to investigate a machine at risk. Next, let's initiate a live response session for another machine so we can look at some other actions you can perform. To respond to certain types of incidents, you can upload files to a library on the device. First, select Upload File to Library. Next, choose the file to. We'll select a PowerShell script that will help us collect event log data on a device for investigation. Next, select Confirm. The script file was successfully uploaded. Now let's review the files in the library on this device. At the end of this list, you can see the file we just uploaded. Now let's run the command to collect event log data. The command ran successfully. You can now use this console to download the event log data and review it locally. Now let's look at how to use third-party forensic tools to gather forensic information from an endpoint machine. First, choose a file to upload to the library. In this example, we'll dump a master file table, or MFT, using the ntfsinfo applet from sysinternals. Next, select the ntfsinfo executable. Now, a simple PowerShell script that will be used to call the executable. Now let's review our library again. You can see that 2 files were successfully uploaded to the library. Next, run the put file command to copy the ntfsinfo file to the Downloads folder for Defender. Now we'll use the PowerShell script to call and run the executable. The executable ran correctly and has dumped the MFT data from memory into a file. Now let's navigate to Power BI to look at some report visualizations. While Microsoft Defender for Endpoint provides extensive visibility on the security posture of your organization through built-in dashboards, Custom reporting can combine security data from multiple sources to create additional insights. These reports were built using data collected by Microsoft Defender for Endpoint Services and exposed through its APIs. Let's review the first dashboard. Here you can see two charts. The Events chart leverages the Advanced Hunting API. Let's select it. Here you can see the Advanced Hunting query used to generate the report. You can use this report to quickly determine if there is a rise in activity and which machines are most impacted. This report can be shared, exported, and even subscribed to as a feed, so your organization's security operations team can receive this report directly in their inbox as part of their daily routine.
You also can use Microsoft Sentinel to hunt for security threats across on-premises and cloud environments by using interactive queries and other tools. So you can use the search and query tools in Microsoft Sentinel to hunt for security threats and tactics throughout your environment. So hunting queries enable you to filter through large amounts of events and security data sources to identify potential threats or track down known or expected threat. So Microsoft Sentinel uses a MITRE attacks framework to categorize and order queries by tactics. And attacks is knowledge base of tactics and techniques that I already told you at the beginning of the session. All Microsoft Sentinel hunting queries use custom query language with the KQL syntax used in log analytics. So you can modify a query in the details pane and run the new query, or you can save it as a new query that can be reused in your Microsoft Sentinel workspace. Bookmarks in Microsoft Sentinel can help you hunt threats by preserving the queries you run in Microsoft Sentinel along with the query results that you deem relevant. You can also record your contextual observations and reference your findings by adding notes and tags. And bookmarked data is visible to you and your teammates for easy collaboration. You can investigate bookmarks in the same way that you'd investigate incident in Microsoft Sentinel. And from the hunting page, select Investigate to open the investigation graph for the incident. And the investigation graph is a visual tool that helps to identify entities involved in the attack and the relationships between those entities. So if the incident involves multiple alerts over time, you can also review the alert timeline and correlations between alerts. You can use the hunting live stream to test queries against live events as they occur. And live streams provide interactive sessions that can notify you when Microsoft Sentinel finds matching events for your query. One of the primary activities of security teams is to search logs for specific events. So, for example, you might search logs for the activities of a specific user within a given time frame. And in Microsoft Sentinel, you can search across long time period in large data sets by using a search job. And while you can run a search job on any type of log, search jobs are ideally suited to search archived logs. And if you need to do a full investigation on archived data, you can restore that data into the hot cache to run high-performing queries and analytics. When you need to do a full investigation on data stored in archive logs, restore a table from the search page in Microsoft Sentinel. Specify a target table and time range for the data you want to restore, and within a few minutes, the log data is restored and available within the Log Analytics workspace. You can use notebooks in Microsoft Sentinel for advanced hunting, and you're a security operation analyst working at a company that implemented Microsoft Sentinel. You want to make sure your security operations team to proactively hunt for malicious activity in your environment with advanced machine learning capabilities. So after developing your hunting hypothesis, you utilize a Jupyter notebook to integrate machine learning libraries, advanced visualizations, and external data to detect malicious activity patterns. You can use Azure Machine Learning to do that. So to go further, I'm going to share you the presentation at the end. So there's some useful link, I think. So you can, if you are interested in being certifying in this area, you should take the SC 200 exam, and you currently have the opportunity to win a voucher by completing the Microsoft Ignite Protect Everything Challenge before next November 9th. So thank you for following these sessions. Thank you. Thanks to the organizers and our sponsors. And do not hesitate to follow the next session.